Okay, this is going to be 2.3 multiplying and dividing radicals. I think if I have a lot of writing, what I'm going to do is I'm going to pause the video just because if I make the video longer than 10 minutes, it tends to desync, which isn't very good. Last year in grade 10 and grade 9, you dealt with FOIL quite a bit, or expanding to binomials. So something like x plus 2 times x plus 3. And if you don't remember that, basically what you do, FOIL is first times first, inside, inside, outside, last kind of thing. Basically, you want to make sure that every term in your first binomial multiplies every term in your second binomial. So x times x would turn into x squared, x times 3 would become 3x, or 2 times x would be 2x, and 2 times 3 would become 6. We then collect all your like terms. You get x squared, 3 plus 2 would become 5x, and then positive 6. And this would have been in grade, it should be chapter, I think it was 3 last year, when we dealt with a lot of factoring and whatnot. When we deal with radicals, we can do the exact same thing, except you have to make sure that your radical is of the same degree, or when you multiply your radicals, you can multiply the numbers underneath the same, as well as the coefficients. So if I have, square root 2 plus 3, I'm going to multiply that by root 3 and 5. I'm totally allowed to do this. Key things to remember is you can multiply the numbers underneath your radicals as well as the coefficients. So, what we're doing with the radicals, we're going to multiply your numbers underneath your radicals. You multiply them together, and any numbers you had in front, or your coefficients, you also multiply together. If there's no number in front, we assume the coefficient is 1. So, root 2 times root 3. It's essentially going to be the square root of, well, 2 times 3 is going to be 6. Root 2 times 5. Now we cannot times a root with a root, or a non-root, so we're basically multiplying the coefficient in front with the whole number. So 1 times 5 would be 5, and then root 2. This is positive. 3 times root 3 is the exact same situation, so 3 times essentially 1 would be 3 root 3. And lastly, we have 3 times 5, which gives us 15. Now, if we could, we would collect all like terms together, but only if they have the same or the same number underneath their radical. We don't, so you can leave it like this. And as far as ordering it goes, if you wanted to, you could order it in the highest radical first, going from then. If you do have a higher degree radical, so something like a cube root or a fourth root, you have that at the beginning. But other than that, our order isn't too bad. So collect like terms. If you can. In this case, we cannot. So we'll give you guys a second example here. So we're going to have 3 root 2 minus root 6. This is going to multiply 2 root 2 and positive 4 root 6. I will use a different color pen to make life a little easier. So, 3 root 2 times 2 root 2. Now, in this situation, we have both a coefficient and the root itself, so we have to multiply both of them. So 3 and 2 multiply together, we're going to get 6 root, and root 2 times root 2 is root 4. And then 3 root 2 times 4 root 6, positive, is going to be positive 3 times 4 should give us 12. And then root 2 times root 6 would be root 12 as well. We're going to have negative root 6 times 2 root 2. So negative 1 times negative 2 is essentially negative 2, and 6 times 2 would give us root 12. And last, we're going to have negative root 6 times 4 root 6. So we're going to have negative 4 times root 36. Now, like last time, we talked about collecting like terms. In this situation, basically we're talking about our root 12s because we have two of them. One thing I'd also like to point out is if you have any perfect squares, you can just convert those to their whole number. So like square root 36 we understand is 6 and square root 4 is 2. So without jumping too much, we know that this now becomes 6 times essentially the square root of 4, 6 times 2, plus we're going to combine these together. And so 12 minus 2 is going to give us positive 10 root 12 minus, and this is going to become 4 times 6. We go one step further to combine. 6 times 2, we've got 12 plus 10 root 12 minus 4 times 6 should give us negative 24. And your last step is to combine everything together, which is going to be 10 root 12. And essentially negative 24 plus 12 would give us negative 12. Now this is one answer. It's not the best answer, but it's one answer. Because usually what we want to do is, if we can, we want to try and simplify or reduce down your radical into its lowest terms. Your book does this quite a bit, so often what usually happens is students will get an answer like this and say, I didn't get the same answer as the back. Well, the back will basically have simplified this. So we can take root 12, and if we recall, root 12 can be broken down into basically 2 root 3, but there's a 10 out front. So 10 times 2, this whole thing would simplify to 2 times 10, so 20 root 3 minus 12. And that is what the back of your book is going to give kind of as a final answer there. So, Alright, so we can make this a bit harder. That's kind of by throwing different variables underneath our roots. So if I have root x, we're going to plus root y, and this is going to multiply 2 root x plus 3 root y. Again, nothing else has really changed too much except for the fact that we've thrown in a different variable under our coefficient. So, same thing's applying. So, root x times 2 root x, so 1 times 2 would give us 2x. Now, x times x turns into x squared, and we're going to talk about that kind of in a couple seconds here. Root x times 3 root y, or 1 times 3, turns into 3, and x times y we can't really do much with, so we're just going to say it's root x y. And we keep going. Y times 2 root x is going to become positive 2 root. Now it's technically yx, but if you rearrange them, it makes your life really easy later on when you go, oh right, xy and yx are the exact same thing. And root y times 3 root y becomes positive 3 y squared. So again, when we go to simplify this, a couple things to remember. We group like things together, and if we can always simplify. If you recall back last year, I'd always tell you that if we ever had to get rid of something squared, we take the root of it. And so the square root of x squared becomes x. And notice that we've got the root of x squared and the root of y squared. So this, right off the hop, is going to become 2 times essentially x plus, brackets make life easy, 3 plus 2 becomes 5 root xy, and we're going to have plus 3 times y. So this would turn into essentially 2x plus 5 root xy plus 3y. And that would be your final answer. Our fourth example, I'm going to write it out first and show it to you guys. I'm going to, actually, you know, before I do that, we're going to remind you guys something we did last year. And they're kind of tricks to dealing with expanding or foiling. I wrote it down wrong. Hang on. Apparently I don't have whiteout. So, if you were to expand this, it's the same binomial, except the middle term, one is positive, one is a negative. So x times x is going to give us x squared. X times negative 1 is negative 1x. 1 times x is positive 1x. And then 1 times negative 1 is negative 1. Basically what happens is, if one's positive, one's negative, we understand that these are going to cancel out. And you're left with x squared minus 1. That's very useful in this next example, where we have root 5 plus root 3. This is going to multiply root 5 minus root 3. You notice it's essentially the same thing, except now we're dealing with radicals to make life a little more miserable. Now, because they're positive negatives, our middle terms are going to cancel out. We'll write it out just to show you guys, but it's probably going to be pretty apparent right off the hop. You'll also notice that when you're multiplying two of the identical radicals together, you're going to get your perfect squares. So, 5 times root 5 becomes square root 25. And then 5 times negative root 3 becomes negative root 15. We get positive root 15. And root 3 times negative root 3 becomes negative root 9. Negative root 15, positive root 15, these guys will cancel out, much like last time. And if we were to simplify this, well, the square root of 25 we understand is 5 minus, well, the square root of 9 is 3. So 5 minus 3, our final answer would be 2. I'm going to stop the video here and make this a part 1, part 2, just because YouTube, after about 10 minutes, I find the audio and whatever I write down desyncs. So this is, we'll continue on for part 2. I'll upload both of them.